Welcome to Millionlights. My name is Pratik Shah. I'm an assistant professor in DY Patil School of Engineering. In the previous module, we had discussed about DC motors and how it can be controlled using Arduino by L29 3D IC. Now in this module, we'll be exploring that concept further. But before starting with that, I have kept the same experimental setup which was used in the previous module's last experiment. The same setup is kept. Now in that, I would like to show you some interesting things. First thing, let me connect this and we'll see the output of that. The output is motor rotating in clockwise direction for 5 seconds. Then it will stop and it will rotate in anti-clockwise direction for 5 seconds. This process is repeated continuously. So now here the speed of motor is less, so we do not have any problem as such. But if we are using a motor which is having a very high speed, then it can be a tedious task, and we don't want to use it at such an high RPM. We want to reduce the RPM, and that is one thing that we would like to take care of. So now what I'll do is I'll remove this slow speed motor and I'll place another motor which is having very high speed. Okay, so I'll unplug it. I'll remove the pin number 3 and pin number 6. So it's taken away. Now I got this small tiny motor. Uh, this is having a very high RPM, and for illustration of its speed, I'm using this fan and I'm connecting it. So you can connect any other things, you can connect wheel or any other thing for your experimentation. So I'm connecting it. Now I'm connecting this to pin number 3 and 6 of the IC. So same setup is used, just one change I am doing is I am changing the pins. Okay, first we'll hold it steady. Okay, so you can see that it is rotating at a very high speed. Stop, clockwise, anti-clockwise. So this is happening at very high speed. Now if I want to control the speed of it's not just good for me to rotate it, I also want to control the speed of it. Then what I have to do? For that purpose, we have to use the concept of PWM, which was explored in the earlier modules. So we are controlling the speed of DC motor using PWMs. How can we do it? That is what we have to study. So let's start with the theoretical part, then we'll get onto the experimentation. Our first experiment will be controlling the speed of DC motor by using PWM. Now for that, first I like to show you the circuit diagram of what we are going to use. It's just a quick recap which was used in the previous module. The same thing is repeated here. Now we can see that pin number 3 and pin number 4 from Arduino are used to control the motor because they are connected to the L29 3D IC. Now if you take a look, or if you go to the previous modules, you will find that pin number 3 is a PWM pin. Now PWM pin means what? From pin number 3 of Arduino we can generate a PWM output, and that output can be given to the motor. So out of pin number 3 and 4, pin number 3 is PWM, so we will generate a PWM signal from this, and with that we will control the speed of the motor. The rest all the circuit diagram is same and the experimental setup is same, just we are changing the code. So if you want to take a look at this presentation, you can see the same thing is used, 9 volts battery is used, we have changed the motor, we have taken a motor with higher RPM, and rest all connections are same. So now let us talk about the code. Now what I am interested in doing is I am interested in controlling the speed of the motor. So it can be done using PWM, and I am using pin number 3. So for generating a PWM signal, we have to use analog write instructions. So that is what I have used. I have used analog write 3, and then I have specified the 8-bit PWM signal that I have to give. So I am making it to rotate at 25% duty cycle, 50% duty cycle, and 100% duty cycle. So the speed will be 100% of the maximum RPM, 50% and 25% respectively. So for that, first thing that I have done is, if you take a look at the code, it is split into two functions: void setup, void loop. Void setup has got two initializations. First one is pin mode 3 and 4, both are output, and pin number 3 is our PWM pin. So I am using analog write in that case, and pin number 4 is our normal pin, so I am using it for ground. So fourth pin is ground, so the motor will be rotating in one direction only. We are controlling the speed of it. So if you take a look at the code, it is having 6 sections. The first section is for rotating it in clockwise direction with a speed of 25% of its maximum capacity. I am using analog write 3,64, then digital write 4 is low because it is the ground pin, and then there is a delay of 5 seconds. That means what? For 5 seconds I am rotating it in clockwise direction with a speed of 25%. Then next part is to rotate it at a speed of 50%. Therefore, I am using analog write 3,127, and then there is a delay of 5 seconds. So it will rotate for 5 seconds at the speed of 50%. Then it will be taking a break of 5 seconds. Once again, we'll have it to rotate at 100% duty cycle. That will be the maximum speed, and then we'll take a break, or we'll pause it or stop it for 5 seconds. So the code is also quite simple. The setup is same. We have to upload the code onto the board, and we have to check whether it's working properly and it's changing or it is giving us difference in speeds. So let's now start uploading the code and we'll see how it works. I have uploaded the code, I have written the code onto the Arduino IDE. Now I'll upload the code onto Arduino and we'll see the results. Now this is the code, same code I have copied for saving the time, and I am uploading the code onto the Arduino board. Yes, now you can see the speed very less. Okay, after this a break for 5 seconds, and then we'll have a speed which is more than the previous one, but it's still not the maximum speed. Okay, so this is 50% of the speed. Then we'll stop for 5 seconds, and then it will rotate at its maximum speed, that is 100% duty cycle. So you can easily make out between the speed differences of it. So you can have various combinations depending upon it. These are the fixed speeds that I'm using. Now this is a very slow speed, that is just 25% of it. Now I'm using it at fixed rates. Now what you can do is you can club them with the value of sensors, and you can dynamically change the RPM rate. Now we'll do a very interesting experiment. In this experiment we'll be using ultrasonic sensor. The ultrasonic sensor is used to measure the distance of any object that is near it, and based on that distance we are going to control the speed of the motor. Now this principle can be used in robots, because if we use them in robots, we can make our robot to move at a very high speed, that is full speed, if there is no obstacle in front of it. So if it detects that there is some obstacle in front of it, like 200 centimeters or 300 centimeters, we can reduce the speed of it. After reducing the speed of it, we can take the decision. So we are going to use ultrasonic sensor for that. First thing that we'll do is we'll mount the ultrasonic sensor on the second section of the breadboard. After mounting it, we have to just connect 4 things. Rest all experiment is the same, rest all connections are the same, just 4 new connections we are doing. First connection is trigger pin getting connected to pin number 12, 8, 9, 10, 11, 12. Okay, then echo pin connected to pin number 11, adjacent to pin number 12. Then we have got VCC and ground. VCC is connected to the VCC that we already made here, and ground pin connected to ground. Okay, so ground pin is connected to the ground. Fine. So this completes with our circuit building. We had just 4 connections: VCC, ground, trigger and echo. Now we have to write a code in which we'll measure the distance, and based on it we'll vary the speed of the motor. Now let's see the code for this experiment. The logic is we are going to measure the distance. The distance is in centimeters, and based on that we are going to control the speed of the motor. Now for measuring the distance we are going to use serial. Okay, serial print is used for printing the display. We are using serial ping cm. So serial ping cm is the method that will be giving us the distance in centimeter. We are storing it in a variable called as a, and based on the value of a we are going to vary the speed. Now the speed can be varied using PWM, and for that we are connecting pin number 3 to the motor, and we are using analog write instruction. Now analog write 3 comma a into 10, I have written that because the distance is multiplied by a factor of 10, and based on that it is sent for the PWM to generate the duty cycle. Now the code is quite simple. First thing is new ping, hash include new ping, we are including the header file. Then we are using new ping sonar 12.11.200, that is we are making a constructor out of it. Then void setup, it has got three things: serial communication, pin mode 3 and pin mode 4. After that, in void loop we first assign a delay of 200 millisecond, then we measure the value of the distance, we print the value, and after that we do one thing: we use analog write for giving the PWM signal. This is very simple code. We are just generating a PWM based on the value of the ultrasonic sensor. Now we'll upload the code and see how the output is. Now let's upload the code on the Arduino board and let's see what the output is. I have already typed the code onto the Arduino IDE. Now we can upload the code on the board directly, and in the meantime I'll pick up the motor. Okay, so it's getting uploaded and it's rotating at a full speed, I guess. Okay, I'll change the baud rate, then I'll be able to see the distance. Okay, so it is rotating at a very high speed because I'm getting the values that are more than 80, 90, something like that, because the distance is more. So what I'll do is I'll place my hand here at a distance of 28, so the speed is getting slowed down. If I come closer, if I move my hand closer, the speed will be reduced, and it is gradually reducing. Now if I place my hand at this place, the speed is very low. Yes, and if I remove it, the speed gradually increases. Once again I'll place my hand in here, the speed should reduce. Yes, it's reducing, and at a particular point when I come very close to it, it will stop. Yes, now because the distance is 2 3, so it is getting very low duty cycle and it's not even possible for it to rotate the motor, and if you remove the hand, it will start rotating. So based on the distance, the speed is varying. So this is one fundamental thing that can be used for controlling the speed of our robots and other things. Now we'll start something very interesting. In front of me I have a robot, a mini robot that I have prepared. Now this is consisting of chassis, wheels, motors. We'll dissect it and we'll understand all the things in detail. Now for making a robot, what you require this chassis. Chassis is what? It is a framework, a metallic framework. Okay, so it looks something like this. This is the main part of it, because this is dependent, and on this the robot strength is dependent, its axis, its dimension, all the things are dependent on this. So chassis can be acrylic chassis or a metallic chassis. I have got a metallic chassis. Depending upon your requirement and all the things, you can have chassis. Now this is having of like dimensions are different, and they have got these holes. These are the holes where you can keep your motors. You can fix your motors here. Now any robot has to have few basic things: chassis, wheels, and wheels that are connected with the motors. So without motors we cannot have robots, and those motors are connected to these wheels. Now in this chassis I have got 4 slots for connecting 4 wheels. So if you want, you can have 4-wheeled robot, or as I have done, you can use that. I have used a caster wheel. This is called a caster wheel. I have used this. This is used for supporting. Now whatever action I want to do, I want to go forward, backward, or whatever I want to do, I can do that with just 2 motors. I can move in all directions, and all the thing can be done with just 2 motors. But if you want to have more speed, more torque, more endurance, and more weight lifting capability, you can go for 4 wheels. So basically we have understood that we require a chassis, wheels and motors. Along with that we also require a caster wheel for making any robot. Now let us see how it is connected or what is the structure. These are two DC motors. The specification is they are of 12 volts. So 12 volts motor are these, and these are I guess 150 rpm motors. So two motors of same rpm. One more thing I would like to tell you, please make sure that the two motors that you are taking are of same dimension, same make, same weight and everything. Because if I connect 160 rpm motor and another one is 120 rpm motor, then if you want to go it if you want it to go forward, it won't go forward, it will go in the left direction or something like that. Or even if you take 120 rpm two motors but they are of different make, it can cause an error that it won't go in straight line, it will go slanted, because both the motors do not have same torque and same power. So we have to take care of that. So take two motors which are having same torque, same rpm, same voltage, made from same company. Okay, so these are two motors that I have fixed, and to the shaft of them I have connected these wheels, and for adjusting the wheels I have used this screw. So if you go to any robotic shop or any electronic shop, you will find the chassis, the wheels, the motors. You just have to connect them, and with the help of this screw you can tighten them and you can fix them. So this is done, and then the caster wheel is also there, you can connect it. Now you will see that there are a lot of slots in here, so they are used for connecting sensors and all. We'll see that in the later part. Now one more thing I would like to show is this, that is the two terminals of your motor are connected, and I have connected them according to that colors and I have taken them up. So in lot of chassis you have got a central section which has got this hollow, or if it is not there you can drill it, or you can make a hole and you can take these things out. So I have taken these out. So what it does is it allows me to control the motors. So this is of left motor, this is of right motor. Now with the help of Arduino or L293D I can control it, I can control the direction. So this is the anatomy of your robot, quite simple, just few basic things are required and we can make it. Now you can use a metallic frame, acrylic frame or any other frame based on your needs and the capacity. You can select the torque of the motor, the rpm of the motor depending upon your requirement. Now let's see how to make this robot move, or what I can say is about the dynamics. Now if I want this robot to move forward, then what I need to do? As I have told earlier, these are the two pins that are connected to the motor directly. Now in the earlier videos what we have seen is that we can control the DC motor using Arduino and L293D IC. So L293D IC has got a capability of controlling two motors. So one motor can be connected to the left hand side part, another can be connected to right hand side part, and based on that we can make this robot to move. Now suppose I want this robot to move forward, then what I have to do is, to this red pin I have to give plus 5 volts and the black pin I have to give minus ground. Same thing has to be followed here, plus 5 and ground. If I do that, my robot will move forward. As you can see, I am manually moving the motors, so this will move forward. So if you are giving supply to it and both are in the same direction, then it will move forward. Now if you want to bring it in the reverse direction, that is if you want to bring it backward, then what we have to do? We have to change the polarity. In this black pin I have to give minus 5 volts, and sorry, plus 5 volts, and here I have to give ground. Same thing is to be repeated, and this will start coming back. So depending upon your requirement, you can make it move forward or backward. Just one thing that we have to follow is the connections we have to see, and from Arduino we have to write the program which will give instructions to L293D to move it forward or backward. Now when we are making it go forward, if you want to stop it, if you want to stop this robot, then you have to take care that simultaneously to the left motor and right motor we are sending the instructions of low low or high high, means both the pins are to be connected to ground, and this also. So all four pins should be going to ground, or all four pins should be going to plus 5 volts. they should be done simultaneously, because if we don't do that, there might be an error. So if you're making this go forward, and suppose I make this one stop, then what will happen? This will rotate, and that is not what we want. So if you want it to stop, then simultaneously both have to be given instructions to stop, and then we can use a delay for that. So this is how we can move it forward and backward. Now we are left with four different things. First one is soft right turn. I would like to say soft right and hard right. There are two turns. First I'll talk about soft right turn. Soft right turn means what? I want this robot to move on the right hand side. How can I do that? There is no steering wheel here. So what we can do? For that, what we do is we keep the right hand side motor stationary, and we make this motor to move forward. So if this motor is made to move forward, what happens? This is stationary and this is moving, this is moving, this is moving. That's it. So it is taking a right turn. But this is called as a soft right turn, because one motor is stopped and the second motor is moving, and it requires a lot of space for turning. The turning radius is high. Now if you want to do it in more effective way, or if you want to take less direction to rotate, or you want to rotate it quickly, then what we can do is we can use a technique that is called as hard right turn. In hard right turn, the right hand side motor is not stopped, it is told to move backwards. It moves backwards and the left hand side motor moves forward. So what will happen is, in the less space and less space and less time, this motor moves. So it is quite simple. Once again I'll show you. That's it. In a very less time and very less space, it can move on the right hand side. So this is soft right and hard right. In the same way, we have soft left and soft hard right, hard left, sorry. The thing here is I want to move it on the left hand side. So what I do is I keep this stationary, and this is made to move forward. So when this happens, it moves and it takes a lot of space, you can see, to move. Now the same thing can be done using hard left turn. In that, I will pull this backwards and pull this forward. So it requires quite a less space and less time also. Now in the last case, it was touching my laptop, but here it is perfectly on the spot, on the same area it is turning, because the center of rotation is on the axis, and therefore it does it quite quickly. So these are few basic movements which we require. No other movement I think we require. We just require front, backward, left and right. uh, so these are the basic things. Now one additional thing I would like to give you is that, if you want to turn 90 degrees, how to do that? There is no such instruction as turn 90 degrees. So you have to calibrate the time required by it to rotate, or what you can do is you can identify the RPM of the motor, and then along with that you can identify the diameter. So based on diameter and RPM, you can find out the time for which I have to give this instruction to move forward. So these are few techniques and tricks that we are going to use. In next videos we'll be covering them in detail, but just an introduction part I wanted to give. So this is how we can make the movements. Now we'll see the other parts such as connection and all the other aspects. Now let's talk about how to mount the circuit onto it. For that I am using the circuit which was used in the earlier in this video. This is the same circuit. Now what I'll do is I'll take this circuit here. Before I'll tell you what I'm doing. Now I want this robot to be functional. That means this should have supply. For this to have supply, this is to be connected to L293. Therefore this breadboard part has to be mounted on top of this chassis. Now this can be done or fixed by using glues or some other tapes we have, so we can fix them onto that. Or if you see on the top of breadboard, we have got this double tape. You can just peel it off and you can just place it on top of it. But what will happen is it will be fixed permanently, so you can find some temporary arrangements if you want. So we can place it on top of it, and then using these pins, we can connect them onto the IC. So this is quite simple, I guess. Now we have to also make an arrangement for this Arduino board to be placed onto it. Now this Arduino can be placed onto it, you can keep it here, or what can you do is you can have a chassis which is a double decker chassis, or which is having two layers. A two layered chassis can be used. So there are various kinds of chassis available. If you go to market, you can find them out. One layered chassis where we have this thing, second one more layer we have where additional thing can be used, or sometimes we can also use triple layer chassis where we are keeping huge batteries. Now I'm keeping this, suppose I keep Arduino also on top of it, done, okay. But how will this circuit be powered? Now the power to the motor and L293D can be supplied by this battery. Actually this battery is having quite less amount of power, but if you want more power, then what you can do is you can get those bulky batteries which are there, you can keep them, they will provide lot of power and they won't discharge quite soon, so we can use them. So this can be used to power my IC L293D. But what about Arduino? I have to connect it to PC. If I don't want to connect it to PC and I want to use it as an autonomous robot which is to be said kept in any place, and it will just rotate and it will keep revolving, but it won't be obstructed, or it won't collide with any object, then so for that purpose I have to use, or I have to use this power section that is available on my Arduino board. So what I can do is this battery can be connected to it, because I am having 9 volts power section and I am using 9 volts battery. So with the help of a connector I can directly plug in into it, or else what I can do is I can make a 5 volts power supply and I can give it to it. So we have to take care of these things also. So I hope this is quite easy to place your hardware onto the chassis and connect. Just I have to make sure that these 4 pins are connected at appropriate place of the L293D, and I can control the motion of it and I can make it work according to my instructions. Now let's talk about various circuits or various types of robot that we can build on it. Now we have seen how this moves. We have also seen how to connect Arduino and how to place the breadboard on top of it. Now with the help of this basic circuitry, we can add sensors and make various different types of bots. The first one can be an obstacle avoidance robot that can be made by using this ultrasonic sensor. We can place ultrasonic sensor at top of it, we can place it somewhere around here, and the signal can be sent to our Arduino. So based on the distance of the object in front of it, what we can do is we can stop, or either we can make our robot to move on the right hand side or on the left hand side. So you can move on the any of these sides and it won't be colliding with the object. So this is one possible way that we can do, or else what you can do is you can use passive infrared sensor for detection of human or presence of any person. Now these kind of things are quietly used in battlefields. Now in battlefields there are few areas where you want surveillance to be taking place, or you want, but in that area you don't want to send people. So in battlefields or in the areas or in coal mines, say you want to check whether any person is struck in there, and you don't want to send any person in there because it is quite risky. So at that time you can use this robot, and on top of it you can use this passive infrared sensor, because this detects heat signal. So it detects the presence of any living human being. So you can connect it and you can place it at top of it, and you can send it at any areas such as battlefields or coal mines or these areas, and it will tell you whether a person is there present or not, or what is the condition, it will tell you that. Then if you want to control this robot by with the help of your mobile, yes, with the help of your mobile you can control this robot. For that we have got this Bluetooth module. So this is a small Bluetooth module, we'll be exploring this module in the next videos. So this is a small Bluetooth module. You can use this module, you can connect this module to Arduino. We have got 4 pins here, just 4 pins are what required. So we will just connect these 4 pins with Arduino, and after connecting it you can give instructions from your mobile. There is a software, there is a my Bluetooth terminal, there are a lot of various different softwares. You can use that, and with the help of that, as we transfer data between two phones, you can connect it with this Bluetooth module and you give instructions from your mobile app through Bluetooth it is transferred, and those instructions are understood by this sensor, and that is given to Arduino, and based on those values you can make this robot move. So there are a lot of things that can be done with this simple setup. So just a frame, a motor, and Arduino connected with these sensors. There's a lot scope which we can do. So people are doing various other things. They're mixing up sensors and making one robot that can do all the things. So in the next modules, we'll be discussing on these aspects, issues, and we'll be making few of the interesting robots. Hope you liked the video. If you have any queries, you can find us on Facebook by the name Millionlights, or even on Twitter. You can visit our website www.millionlights.org for more such interesting courses. Thank you.